In this video, we're going to find a missing angle measurement when we know two sides using trig ratios. So up here, I'm going to write SOH, CAH, TOA. To remember those ratios, I'm going to remind you that you should always be working in degrees right now. And we're going to do the first thing that we did with the previous problems, and that's label the sides that were given. So here's the right angle. 8 must be the hypotenuse. And then here's my reference angle. So this is right next to it, so this must be adjacent. That means I'm going to work with the cosine trig ratio. My reference angle is unknown right now. And then it's adjacent over hypotenuse. Now this is weird because we need to get theta by itself, but it's being cosigned. So if theta was being multiplied by 4, we would do the inverse operation and divide by 4. But theta is being cosigned, so we're going to do the operation of inverse cosine. An inverse cosine is written like this. It is not cosine to the -1. Don't call it cosine to the -1. It's inverse cosine. So in order to do inverse cosine, what we're going to do is we write cosine with that -1 up on top. We put our ratio here and we put it equal to theta. So that's how we get theta by itself. Now, your calculator has this inverse cosine. Again, if you have the TI Nspire, look it up online on how to switch over to inverse functions on the TI Nspire. If you're using a calculator, like if you flip your iPhone to go sideways, it has it as an option. If you go to the Desmos online calculator, it has it as an option. If you type it into Google, it has it as an option. So you type this away, make sure you're in degrees, and if you are in degrees, you should get 41.4 degrees is what theta equals. If you're not getting this answer at all, you might be in radians. I want you to round angles to 1 decimal, please. Number 2, same scenario. We're going to label the sides. We've got the right angle here, so across from it's our hypotenuse. And across from our reference angle is our opposite. We're working with opposite. We're working with hypotenuse. It's a sine ratio. We don't know our angle measurement. And it's equal to our sine ratio of 14/50. In order to get our angle measurement by itself, we're using that inverse sine function. We put our ratio inside of it, and we have it equal to theta. We type this in our calculator, and we get a 16.3 degrees for theta. Notice how I keep writing degrees. You need to write degrees. Degrees is a unit, and later on it'll get confusing if you don't write degrees because we're going to work for another unit of measurement for angles. Lastly, we're going to try this one. Again, label the sides. We don't label the hypotenuse. There's nothing there right now. So this is across from the reference angle, so it's opposite. Leaving this one to be adjacent. Adjacent and opposite, we're working with a TOA, a tan. Opposite over adjacent, the ratio is 68/51. We want to solve for theta, so we want to do that inverse. Something I've seen in the past is people multiply this by -1. That's not what that means. Inverse tan is a button. Don't try to multiply. Yeah, don't do that. Just don't do it. Do inverse tan of 68/51, and you should get 53.1 degrees for theta. And that's it for finding an angle when you have two sides.